Good morning, I'm Dr. Janardhana Rao, working in Aeronautical Engineering College as associate professor. Since a few classes we're discussing about operating systems, and today our topic is file allocations. Already we have discussed what is file, how the file is created, how the file is saved in the directory, under the directory of indexing, all these things we have studied. Now we are going to discuss about how the file is loaded in the hard disk. So that's our concept. Today, I'll give you some introduction about this one. So in this one, see allocation methods, file allocation method. The allocation methods define how the files are stored in the hard disk. Hard disk. So we have seen that the OS will OS like Unix considers everything as a block. So now, how this is saved in the blocks. That is so now if you look at this hard disk, it seems like this. Okay. So in this case, if you look at here, so this is your as I told, first line, this address will be there some 0, 1, 2, 3 like this. The lines. So 1 KB means 1000 lines, one block. This is one block. So like this, the blocks will be created in the hard disk, and when for our study purpose, we will see how the block is converted into some box type. Okay, we'll see there are three main tasks, three main disk space or allocation methods. One is continuous allocation, linked allocation, indexed allocation. So we'll see what is this. We know the block already understood. The hard disk is divided into blocks, and if you look at this coming diagram, so if you look at this one, this is allocation methods as we discussed now. This continuous allocation, extends, linked allocation, clustering, FAT, indexed allocation, linked allocation, linked indexed allocation, multi-level indexed allocation. We'll see one by one. So here, so block, this is our hard disk only. So for our study purpose, we have created block 0, block 1, block 3, 2, 3 like this. So whereas this is your hard disk. This is block 1, block 2, block 3 like this. For our study purpose, this 1, 2, 3, 4 are made like this. Only this like this only. So here, if any file is saved continuously, suppose each block size is 1 KB, 1 KB block size are there. So suppose any file is having 3 KB, if the 3 blocks are free, nothing is saved in these blocks. So we can save this file in these 3 blocks. So this is since our file is saved in continuously, this is called continuous allocation. Very simple. So like this, continuous means file is saved in these 3 files continuously. This is called continuous allocation. So in this one, so if the blocks are allocated to the file in such a way that all the logical blocks of the file get the continuous or continuous physical blocks in the hard disk, then such allocation scheme is known as continuous allocation. This is one thing, continuous. If any file is there, so we are allocating the space in the hard disk continuously, continuous space, not one block here, 1 block here, 1 block, 1 KB here, 1 KB here, like this. So if you saving like this, this is not continuous. So continuously means the blocks are neighbor blocks continuously. This is continuous allocation. If the 3 blocks allotted for that file, this is called continuous allocation. Okay. If the blocks are allocated to the file in such a way that all the logical blocks of the file get the continuous physical block in the hard disk, then such allocation scheme is called continuous allocation. So in the image shown below, there are 3 files in the directory. The starting block and the length of these blocks are mentioned in the table. In the table, the contiguous blocks are assigned to each file as per its need. So this is file name, starting block, length, how many blocks it takes, and allocated blocks 0, 1, 2. This is called contiguous allocation because that file is allotted starting and this one continuously allocated. This is called contiguous allocation. The starting block and the length of each file are mentioned in the table. In the table, the contiguous blocks are assigned to each file as per its need. So because that particular file requires 3 blocks, so 3 blocks allotted, and starting and ending. So we should know where it started, where it is ending, how many blocks it is allotted. So the table will be maintained in the directory. This is what contiguous allocation. So the next one is, we'll see what are advantages. We'll see advantages of the allocation method. This contiguous allocation methods. It is simple to implement. Okay, we will get excellent read performance. Supports random access into files. So what are disadvantages? The disk will become fragmented. Fragmented, and it may be difficult to have a file grow because suppose if you look at this one, so this is our file blocks. So if you allocate some 5 instead of 3, length is 5 or 4, length is 4. So now these 4 blocks allotted for this file. So some other file it required again 4 blocks allotted, but what are these 2 blocks? It is 2 blocks not occupied. So there may be, if any file requires 2 blocks continuously, then only you can allot these 2 blocks. Otherwise, we cannot allot these 2 blocks. These 2 blocks kept vacant. So like this, there will be wastage of memory blocks in this contiguous allocation. So these are the disadvantages in this continuous allocation. So if you go to another method, linked list allocation. The linked list allocation, so linked list allocation solves of contiguous allocation drawbacks. In linked list allocation, each file is considered as the linked list of disk blocks. The disk blocks allocated to particular file need to not be continuous or continuous on the disk. Each disk block allocated to a file contains a pointer which points to the next disk block allocated to the next disk allocated. In the sense, if you look at this diagram, in this one, so there will be pointer for like this. If the file, if this is if 2 are not free, so automatically it will point like this. It will point like this. Keep on this. If the file is saved in different blocks, not continuous allocation, not continuous. In that case, that linked list, what we have learned in that data structures linked list like this, there will be pointer next block pointing to next block. So it indicates that the data is saved in the different blocks by using the linked list data structures. So we can overcome what is drawback in the continuous allocations. That's what. So there will be link from one block to another block. So if the file is not loaded or saved in the continuous allocations in different locations, these blocks are allotted. See, 7th block, 7 to 10, like this. There will be linking of the file where it is saved. That's the blocks are linked like this. So this is called linked list allocation. So the disk blocks are allocated to a particular file need not be continuous or continuous on the disk. Each disk block allocated to a file contains a pointer which points to the next disk block allocated to the same file. So what are the advantages of this one? Advantages of continuous allocation. I mean, this is a disk linked allocation. So there is no external fragmentation. Already we have seen fragmentation. What is fragmentation? Fragmentation is called wastage of memory. So even if one block is available vacant at somewhere else, So automatically it will be pointed. So we can minimize the wastage of the link of the data or of the memory. Any free block can be utilized in order to satisfy the file block request. So file can continue to grow. Suppose if you saved one file, that file is some size is 20 KB. So 20 KB it may be saved in the two blocks. So further, one more we have done some modifications. So we added something else to this file. So now size is increased to 30 KB. So still another block is added to this one, so that file can be increased. So that is the meaning of this one. File can continue to grow as long as the free blocks are available. So free block will be allotted to this one. So there is no restriction for the file size. We can increase as per the requirement. So directory entry will only contain the starting block address only. Starting block addresses you will see. So advantages, disadvantages. Random access is not provided. So because each block is pointed by some other block. So suddenly you cannot randomly access in between, because one block is pointed to the another block. Another block is pointed to another block. So this is linked. So we cannot get the linked for each block. So we have to follow one by one sequentially. That is called random access not provided. Pointer requires some space in the disk blocks. As we know, this is as you know, random access is not provided. Pointers require some space in the disk. So in the each block, we require some separate space for pointers. So that is another disadvantage. So pointers require some space in the disk blocks. Any of the pointers in the linked list must not be broken, otherwise the file will not get corrupted. So these are the disadvantages of the linked allocation. So random access is not provided. Pointers require some space in the disk blocks. Any of the pointers in the linked list must not be broken, because in case of any link is broken, that the complete scenario will be changing. So the file will get corrupted. So this is a drawback of this linked allocation, and need to traverse each block, because we have to travel from one block to another block, because next block address will be loaded in the previous block. So like this, each block is connected by each other. So like this is the concept of a linked list, and we'll see the indexed allocation. This is a third method. So in this indexed allocation, instead of maintaining a file table of all the disk pointers, indexed allocation scheme stores all the disk pointers in one of the block called indexed block. So indexed block doesn't hold the file data, but it holds the pointers to all disk blocks allocated to that particular file. Directory entry will only contain the indexed block address. Suppose this is our hard disk, and these are the blocks. These are blocks. Block 1, 2, 3, 4, like this. And so if one file is allocated space, suppose then one block will be taken as index, and this will show where the data is saved in the which blocks. So this is index blocks. And what are the blocks allotted for that file, that will be noted in the one of the block in the hard disk. So this is called indexed allocation. So now file is saved in this file, in this block, like this. So all these file in front of that file name, some XYZ. So what are the file block numbers there? That 2, 3, 5, like this. It will show in this file. So it means that the file is saved in these blocks. So that automatically, this is called indexed blocking. This is indexed blocking, and we'll see the next coming allocation method is, this is single level indexed allocation. In the indexed allocation, the file size depends on the size of the disk block. To allow large files, we have to link several index blocks together in a linked index allocation. Small header giving the name of the file. Set up the first 100 blocks addresses pointed to the another index block. So for the larger files, the last entry of the index block is pointed to the which points to another index block, because we have see if the file is file size, block size is less, and if file size is more, in that case the file is saved in the file is saved some files. This is your index blocks, and the file, these are the where the file is saved in different like this is index blocks. So the same file is saved also in the another blocks. So again, this will indicate another index blocks like this. So like this, this is indicating another block. This is single level linked index blocks, because it depends upon the file size. If the file size is more, some files and block size is less, so they'll use two different or three different indexing blocks, and these index blocks are linked after that. This is called single level linked allocation. So it attributes allocation methods you have seen now, pointed to the next block, index block. So this is advantages. It removes file size limitations. There is no limitation for this file size. So next disadvantages, random access becomes a bit harder, because as we know, it is possible in the indexed allocation, random block you can reach, but we have to go to the block size, indexed block, and we have to see the where the file is saved in different blocks, and we have to find out which block randomly we can access the blocks. So this is, so that we have seen. So multi-level indexed allocation. In multi-level indexed allocation, we have various level of indices. There are outer level index blocks which contain the pointers to the inner level index blocks, and the inner level index block contain the pointer to the file data. The outer level index is used to find the inner level index. The inner level index is used to find the desired data blocks that we have seen. So as a file size is more, we use different more than one index block, and this one index blocks is connected to, this is one index blocks, and this is connected different blocks. One, this is block 5, 6, 10. So block 5, 6, 10. This is index block 1. So similarly, file is saved in some other blocks also, 20, 30, like this, 20, 30, and this is both are interlinked. Like this, this is called multi-level. Another index box also closed, opened, and what are the blocks where the blocks the file is saved, that is 100, 120. So these are both are linked. This index box contains the where which data block the data is saved, the file is saved. That is, and each index block is interlinked. So automatically there is no limitation for the file, because let it the files is anything, any level or any file size, then automatically we can provide the files blocks for that file. That is no limitation. So access time for a file will be higher, because there are indexing blocks are interlinked. Apart from the data blocks are also linked to the index blocks. So now the outer level index is used to find the inner level index. So inner level index used to find the desired data blocks where the file is saved. So that is thing. So if you want to access a particular file, particular block, so we have to search first in the index blocks, which index blocks that indexed block that file is falling, that data is falling, and you have to first find out, and then we have to go over there. So random access becomes better and efficient. That is the advantage of this multi-level index block allocation, and we can save large files also in the multi-level index allocation. So allocation methods is, you see, outer level index blocks. This is outer level, that is index. This is one index maybe 100 or 20. Just you see, like this, there are 20 index blocks are there. So each index blocks is given like this. So disk blocks, pointers. This is a disk blocks, and where which the data is saved. Like this, we will have large size files also we can allot the data. This is the thing. So next we will see free space management. What is with this free space management? So if that all we are saving the files in the hard disk one by one, wherever the place is available. Once disk is full, so it's not like that we will delete the files in serially, because suppose this is our hard disk, we saved on, this is a memories allotted for the different files, some 1 2 5 6 10 like this. So if one file is saved, all these files are saved like this. See, if this file is deleted from the hard disk, those no free space is available there. So another file is removed here, so deleted. So again the free space is available here. So this is called free space, because some space is available here, some space here available here. So both, if you combine both, it will get the space for the a bigger file. So that is how the free space can be managed. That is, free space management is very crucial. So you can increase the memory size for the a bigger file. So this is nothing but the system keeps track of the free disk blocks for allocating space to files when they are created. So one file is created, the OS will check where to be loaded in the hard disk, which block is free. So to reuse the space released from the deleting files, free space management becomes crucial. That's what I'm discussing. If one is deleted from the hard disk, so whatever the space available or created, so that space can be reused for the saving the another file, because it is a continuous process. When we delete one file and we save another file, it is continuous process. So the system maintains a free space list, because which block is free, and once you delete one file, so it will delete some data from the blocks. So that space, which block is free. So the system will maintain a free space list which keeps track of the disk blocks that are not allocated to some other file, because once you have deleted some file, so that blocks are free. So that list will be maintained by the OS. If the free space is available, then allocation disk space to the new file, because it is continuous process. If one file is deleted, after some time you may save another file. So where that new file will be saved, they are subject to availability of your blocks. So that is, whatever the file deleted and the space is created, in that space we must be able to load another file. So that is, we are allocating that block to new file. So after that, the allocating space is deleted from the free space list. So whenever we delete a file from, then its free memory space is added to the free space list. Once, just you see, if you go to a hotel, if you book a room, after some time we'll vacate. When you book a room, and they will make an index on the front of this inquiry. So which are free, which rooms are free. Once if that room is vacated, automatically they will update that which room is free. That is same thing. That is whenever we delete a file, then the free memory space is added to the free space list. Which room is vacant now. So that is nothing but indexing to the. So same way here also they maintain the indexing. The process of looking after and managing the free blocks of the disk is called the free space management. So whenever the file is allotted or file is saved, and which blocks are given to that file, so that is maintained. And whenever some other time when you delete a file, certainly that block should be freed from that file, because file is freed or deleted from the hard disk. So these are some methods or techniques to implement a free space list. These are as follows. A bitmap or a bit vector is a series of collection of bits where each bit corresponds to a disk block. The bit can take two values, 0 and 1. Zero indicates that block is allocated, and 1 indicates free block. So as we know, just I give the example of hotel. If you go to any hotel, if you book a room, that will be blocked or zero. It indicates zero. No room is available because they will maintain the list. So similarly, the free space management also maintained by the OS in the hard disk. So the given instance of disk blocks in the disk figure where green blocks are allocated and can be represented by bitmap of 16-bit like this. So the block number can be calculated as for this one. So the number of bits per word, number of zeros per word offset. So this is one of the technique to indicate into space creates. I mean, to indicate what is the free blocks available in the hard disk. So linked list. It is another approach for free space management. The approach indicating green, so that this approach suggests the linking together all the free blocks and keeping a pointer in cache where points to the free blocks. Just if you look at this diagram, so all green are free. So like this, these are the block 5, block 6, block 7 blocks. Green are occupied, and what is the available here? That is free. So now free. What are the free blocks available? That we make a link list, and it shows that these blocks are free now. So we can save any file in these blocks. So all the free blocks on the disk will be linked together with a pointer. Whenever a block gets allocated, its previous block will be linked to its next free block. So OS will allocate some blocks. Once automatically the linked list of these free blocks will be getting updated. That's it. A drawback of this method is IO required for free space like list traversal. So grouping. This is another technique. In this approach stores the address of the free blocks in the first free block. The first free block stores the address of some say n free blocks. Out of these n blocks, the first n-1 blocks are actually free, and the last block contains address of the next free n blocks. So like this the grouping. So continuously we cannot listing only. These are all indicating which free blocks are available. So they're grouping like this. The address of group of free blocks can be found easily where the free block is available. So next one is counting. So what is this approach stores the address of the first free disk block and a number of n of the free contiguous disk blocks that allow the first block. Every entry in the list would contain address of the free disk blocks, a number n. So that is, this in the case of it is continuously how many blocks are available, counting continuously how many blocks are available. So that is our counting. So we will discuss the rest of the concepts in the coming session. In the coming session, we will discuss about directory implementation in the operating system can be done by using single linked list and hash table. That we will discuss in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.